All right, good morning, my loves. I hope everybody's doing okay. This is part 2 of the 10.1 confidence intervals video. So thank you for bearing with me. I finished the last one last night a little late. I was like, I need to not try to do this exhausted. So here's the second part. We're going to work through these 2 practice problems. If you feel confident based on what you saw on example problem 1, if you want to hit pause and try to do example problem 2 on your own, go for it. And then you can kind of fast forward and check your answers with me. I definitely want you to do that for example 3. But for example 2, it's optional. If you feel comfortable, go ahead and try it on your own. If you don't feel comfortable, just do it along with me and watch and see how it goes. And at the end of this video, we're going to talk about the outline for the week and what I'm anticipating you guys, your work schedule on that. And we'll go from there. All right, so example 2 is dealing with opinions about gun control. So it says, Gallup regularly asks random samples of U.S. adults their opinion on a variety of issues. So they said in a poll of 1,011 adults, U.S. adults in January 2013, 38% responded that they were dissatisfied with the nation's gun laws and policies and want them to be stricter. In a similar poll of 1,011 adults in January 2012, only 25% agreed with this statement. All right, so they want us to do a 90% confidence interval and then use that confidence interval to decide whether we have convincing evidence. So the first thing we have to do is go through and figure out what's what. So for this first one, I am going to, well, I will when this decides to cooperate. All right, so I think that I'm going to count as my P1, my P hat 1. And then for this one, that'll be my P hat 2. So 2013 is going to be my P1 and P hat 1, and 2012 is going to be my P hat 2. You could totally flip-flop that. If it bothers you that your 1 is after your 2, you could totally flip that and make P hat 1 be 2012, P hat 2 be 2013. It doesn't matter, just as long as you're consistent. So I'm going to go ahead and label those for myself. So that's going to be P hat 1, of course. Yeah, that jumpy thing's going to be real annoying on the video, isn't it? Alright, so P hat 1 is going to be my yellow, which was 2013. And then my green's going to be P hat 2. But like I said, you do you. Alright, so if we're going to do a confidence interval, so that means we've got to do state, plan, do, and conclude. So the state, we've got to say what our parameter is, and then we've got to find our statistic, since there's actually a little work that needs to be done there, and then our confidence level. Alright, so our parameter is going to, well, hang on, let me catch up. So state, our parameter is going to be P1 minus P2. And that is the difference in proportion of U.S. adults who want stricter gun laws. Alright, then our statistic is the P hat 1 minus P hat 2. So we can actually get numbers for those. P hat 1 should be 0.38 and P hat 2 should be 0.25. They went ahead and gave us the percent, so we didn't have to do any work on that one. Alright, so when I subtract that out, I'm going to get 0.13 as my statistic. And then the confidence level we're going to deal with is 90%. Alright, so that's our state. We've gone through and included all of that. If you want to put a little more information in the statistic, you could go and include your sample sizes there. You don't have to, but if you just want to have all your information in one spot and that way you're not referring back to the paragraph, that's totally fine. All right, and then for our plan, we need to label what we're doing and then find our conditions. So this is a 2-sample Z interval for P. All right, for random, they said they're random samples. All right, and then for the 10% and the large count, remember we have to talk about both samples. So for the first one, for P1, and actually P2 for both of them, the sample size is 1,011 adults. So 1,011 adults is less than 10% of all U.S. adults. If you wanted to write that twice, you could. You could also say, both samples are the same size. Some indication. Just make sure that, or you could even write ×2 after it. I would think that would count. Just make sure that you are indicating that there is more than one sample there. For large counts, it's a little more tedious. So N1 times P hat 1 has to be greater than or equal to 10, and N1 times 1 minus P hat 1 has to be greater than or equal to 10. So N1 is 1,011. P hat 1 is 0.38. And when you crunch the numbers on that, you get 384.18, which is definitely bigger than 10. And then for 1 minus P hat 1, that gives you 0.62. I'm running out of room there a little bit. So we end up with 626.82, which is also greater than or equal to 10. So for the first sample, we're good. Now we got to do the same thing for the second sample. So N2 times P hat 2 has to be greater than or equal to 10. Sorry, the stylus is being stupid for some reason. All right, and then N2 also has to be bigger than 1 minus P hat 2. All right, so it's still 1,011. P hat 2 is 0.25. So when you multiply that out, you get 252.75. And then over here, multiply that times 0.75, and we're going to get 758.25. So both of those are also bigger than 10, so we officially meet all of our conditions and we're good to go. Alright, so now we have to actually crunch the numbers. So for our do, we have statistic plus or minus critical value times our standard deviation. So our statistic is P hat 1 minus P hat 2 plus or minus D star. Alright, and then the standard deviation formula is the one that's a little more complicated. So square root of both of the standard deviations, the standard deviation of each sample. So P hat 1 times 1 minus P hat 1 over N1 plus P hat 2 times 1 minus P hat 2 over N2. Alright, so plugging in our numbers, that's going to be 0.38 minus 0.25. And then if you go look up on your chart back in the appendix, Z star for 90% should be 1.645. And here's our standard deviation calculations. So P1 is 0.38 times 0.62 over 1011. And then 0.25 times 0.75 over 1011. I'm going to run out of room there. Alright, so when we're doing this next part, you want to be careful that you are leaving enough room for you to do this, but also when you're putting this in your calculator, you want to be super careful that you're getting your square root put in correctly. Alright, so we did this first part already. We know that that is 0.13. And we have our z star. So now what we need to find out is that square root. So control square root. Oops, hang on. I gotta turn this to so square root, fraction, and put in all our info. So 0.38 times 0.62 over 1011 plus, add another fraction, 0.25, ignore my Slack chat, forgot the decimal, so 0.25 times 0.75 over 1011. Okay, proofread for a second because you just typed a whole bunch in and it's easier to look now to fix things than to do it afterwards. Looks like I put that in correctly. Alright, and I ended up getting 0.020. If you wanted to tag that 4, which would then turn into a 5 on the end, you could totally do that. So I'm going to do my multiplication, 1.645 times that answer, and I'm going to end up with this. 0.13 plus or minus 0.0337. If you stopped at 0.033, that would be okay as well. No issues there. Alright, so that's my confidence interval. If you wanted to jump and go ahead and do your addition and subtraction, that would be fine. You'd end up with 0.0963, comma 0.1637. So either way is fine. So the last thing is to conclude, and that's where you're writing your sentence. So we are 90% confident at the interval from 0.0963 to 0.1637 contains the true difference in proportion. Of adults who favored gun control. Okay, so that's your conclusion. So remember when we work these problems, we always want to double check that we answered everything. So all of that work was unfortunately just part A. Part B asked us, so what do we think? So it says, based on the interval, is there convincing evidence that opinions about gun control have changed? Alright, so what we need to do is go look at our interval. So both of our numbers inside the parentheses are positive, and remember we made that chart on the third page of your notes? Nope, page 4 of your notes, that talks about, let me just scroll up, it'll be faster. Well, maybe it'll be faster. There we go. There it is. So on that chart right there. So both of ours are positive, and so that means our P1 is larger than P2. So P1 in this problem we said was 2013, and P2 was 2012. So if P1 is bigger than P2, is there convincing evidence that opinions about gun control have changed? Yes. P1 is now larger. The proportion of adults who favored gun control increased from 2012 to 2013. So yes, our confidence interval indicates that the proportion of adults in 2013 increased from the proportion of adults in 2012. Okay, so yes, our confidence interval indicates that the proportion of adults in 2013 increased from the proportion of adults in 2012 who support gun control. All right, so we're good with number 2. So I would recommend that you pause now and try to do number 3 on your own, and when you get stuck, come back and turn the video. Or if you get all the way through it, awesome, come back and turn it on and check your answers. I'm going to go ahead and narrate number 3, though, just in case anybody still needs a little more help with it. But hopefully you're getting the rhythm of it, because it is so very similar to what we were doing before break. But I also know it's been 2 weeks since we've done that, so we might have forgotten just a little bit. All right, so jumping to number 3. It says to study the long-term effects of preschool programs for children from low-income families, researchers designed an experiment. They recruited 123 children who had never attended preschool from low-income families in Michigan. Researchers randomly assigned 62 of the children to attend preschool, and the other 61 to serve as a control group who would not go to preschool. One response variable of interest was the need for social services as adults. Over a 10-year period, 38 children in the preschool group and 49 in the control group have needed social services. All right, so we're going to do a 95% confidence interval, and then we're going to, based on that, say whether there's convincing evidence that the treatments weren't equally effective, meaning there's a difference between the two. All right, so just going in order, the preschool group is going to be my P1. And then the not preschool group will be my control group, will be my P2. I really recommend, whether it's highlighting, whether it's underlining, something like that, because you're going to get all the way to the end of this problem and be like, crap, what was my P1? I'm going to forget. So if you just go ahead and label it, it's going to make your life so much easier. All right, so state plan do conclude the whole thing. So for state, our parameter is P1 minus P2, and that's the proportion of children who needed social services. I can spell. All right, what did I leave out of there, y'all? Should be the difference in proportion, because we're subtracting. So the difference in proportion of children who needed social services as adults. All right, for our statistic, we've got to do a little more work because they don't give us the percents. So p hat 1 should be, I said that was the group that goes to preschool. So that would be 38 out of the 62 that went to preschool. And 38 divided by 62. Okay, so your calculator defaults to fractions. So I know some of us, we've talked about this, but in case you forgot, if you hit menu and then number 2, and then there you get convert to decimal. So you can tell it to override it and go to a decimal. All right, so we end up getting 0.613 as our proportion for the preschool group. For our proportion that was not preschool, that was 49 out of 61. Jumping back over here, 49 divided by 61. And get that. We're going to turn it into a decimal. And we get 0.803. So for our statistic, it's p hat. Yikes. All right, so we have p hat 1 minus p hat 2, which is going to be 0.613 minus 0.803, and we're going to get a negative p hat. So 0.613 minus 0.803, and we're going to end up with negative 0.19. It is totally fine to have a negative statistic there. Don't let that freak you out. All that indicates is from our samples, the second one was larger. And we're going to go the whole way through our confidence interval to see if that holds true for everything. All right, last thing we have to do is say our confidence level, which was in this one 95%. Okay, so there's our state. So plan should be a 2 sample C interval. For P. All right, for our conditions, they say in there that researchers randomly assigned to the 2 groups. For 10%, we're talking about children from low-income families in Michigan, and 62 and 61 respectively would more than likely be less than 10%. All right, and then for large counts, again, we have to go through and work this for both samples. So the first one has a sample size of 62. So it's 62 times 0.613. And then, so when we subtract that, it's going to be 0.387 that we're multiplying by. And we end up with 38.006 and 23.994, both of which are bigger than 10. So we're good there. Now we have to do the same thing for our second sample. Sorry, this thing is definitely having trouble with all the writing on the file. Well, okay. Wasn't exactly what I had in mind, but that'll work. 23.994. Alright, now we have to do the same thing for our second sample. Alright, so this one had a sample size of 61. Our p hat was 0.8. Multiplying that out, we're going to have 48.983, which is bigger than 10, so we're good there. And then 12.017, which is also good there. Alright, so we pass all of our conditions. So now we can jump into the do. So it's statistic plus or minus critical value times standard deviation. Remember, that's on your formula sheet. And then this will be p hat 1 minus p hat 2 plus or minus z star. And then we've got our standard deviation formulas. So n1, I lied, p hat 1 so p hat 1 times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p hat 2 over n2. Okay, plugging in our numbers, that's going to give us 0.613 minus 0.803. The z star for 95% is 1.960. And after we substitute all of that in, we're going to end up with 0.0801 right there. And then when we multiply that out and do our subtraction and everything, we're going to end up with negative 0.19 plus or minus 0.157. And as an interval, that's going to give us negative 0.347 to negative 0.033. Alright, when we write our sentence, we are 95% confident that the interval from negative 0.347 to negative 0.033 contains the true difference in needs for social services as adults, based on attending preschool or not. Alright, so all of that was part A again. Part B says, based on the interval, is there convincing evidence that the treatments weren't equally effective? Alright, so yes, there is convincing evidence. Our interval, both of them were negative, which means that our P2 would have to be negative. So P2 was the proportion of students that did not attend preschool. And so the proportion of students that did not attend preschool had a higher rate of needing social services. And so the treatments were not equally effective. Going to preschool reduced the rate that someone would need social services as an adult, while not attending preschool increased the rate. All right, so the whole point with these confidence intervals is when we're doing an experiment and we have two different things and we want to see if our results are actually make sense. So, in this case, they did two groups. One group went to preschool, one group did not, and that was it. They didn't run this trial multiple times. They just had it based on one sample. And so by going through these steps with a confidence interval, what we're doing is we're saying, can we take this sample, our results from this one experiment, these two samples, and is that enough for us to make a big sweeping generalization? And so if you go through the steps for the confidence interval, it can be. Now the significance test that we're going to talk about in the next part of this section gives you a little more weight, but with a confidence interval, you can go ahead and kind of start to make some generalizations based on that. Okay, so I want to talk real quick about the outline that you guys got. Let's see, I pulled it up. Here we go. All right, so this is what I posted on Canvas. This is kind of the outline for the week, but it's real loose. So this is when I'm going to release the material. You just need to work on it over the course of the week. So this is the second confidence intervals video. I'm going to post this obviously as soon as I'm done. There is 4 homework problems that go with it. 5 and 7 are just talking about conditions. 9B and 11 go through the whole process. So these take a while, just like the last ones. So I'm not going to ask you to do 85 million of them. We're just doing 2 for homework. The answer key will get up as soon as I have it worked, and I'll post it on Canvas. Then tomorrow, I'm going to post the videos for doing a significance test for this. Again, same steps, mostly same formula. It's just tweaking it just a little bit. And I did not adjust those homework problems, so I will adjust that and let y'all know that I made a change there. I'm going to have office hours tomorrow from at 4 o'clock on Tuesday. Wednesday and Thursday, I'm not posting anything new. I will more than likely post the one sheet and maybe some extra practice problems if there's a desire for them, but otherwise that's it. And then on Friday, I'm going to post a TWIZ, but it's not going to be a quiz grade. It's going to be a completion grade. Do the best you can on it. I'll give you an answer key. We'll talk through it, see where there are concerns. Okay? But it's not going to be like a traditional quiz grade. I just don't feel good about that with us not being there. But I also hear you that a lot of you would like some grades to kind of help boost your average a little bit. So we're going to count it as a completion grade. If you get it turned in, awesome. But you'll get a chance to kind of check yourself and see where you are. I'm also going to have office hours on Friday. And I'm going to release that TWIZ on Friday. It's not actually going to be due till Saturday night. I would like them on Saturday, though, because that means I can grade them on Sunday and then release them back to you. So that would be super helpful. I'm leaning towards having you just take pictures and upload it because I think otherwise it's too insane to try to type that into Canvas. that just seems a little crazy. But, you know, if you really want to, that's fine too. And I think that's it on the calendar, so I will get back to you about that homework assignment. I thought I adjusted that, and I obviously didn't, so I will tweak that and get it to you. All right, everybody, have a good week. If you have questions, shoot me an email and let me know, and I'll put the significance test videos up tomorrow. Thanks a lot. Bye.